to this stats chat. In this episode, we're going to take a moment to review measures of variability. Some of the key measures of variability are standard deviation, variance, and range. All three of these measure the spread or the variation of the data. And you can also look at these items in SPSS output, which we'll talk about more in a later video. This is a sample instrument. It is the TEQ, the Trait Emotional Intelligence Questionnaire short form. This was used in a study by Harachand and colleagues in 2017, published in the Virginia Counselor's Journal. And this was a measure used to evaluate trait-based emotional intelligence and explore the correlation between trait-based emotional intelligence and burnout. As you can see, a sample item starting with number 1 is expressing my emotions with words is not a problem for me. And these items are ranked on a Likert scale from 1 to 7, where 1 represents completely disagree and 7 represents completely agree. So this is a trait-based self-report measure of emotional intelligence. Now, in another study that looked at an empathy training and the influence of that empathy training on well-being, the Trait Emotional Intelligence Questionnaire was used as the post-test. And in this SPSS output, we see the Trait Emotional Intelligence Questionnaire post-test total, as well as the well-being total. And we can see the range here, the minimum value and the maximum value. So 2.76 as the min, 4.38 as a max. Here we also see the standard deviation reported, and we can calculate the variance by squaring the standard deviation. So we can get all of this information from the SPSS output. And then the range, we can subtract the max value for the post-TEQ well-being score, which is 5.28, max, min 3.16, and get 2.12 as the range. What do you notice about the means of the treatment group and the control group for the Trait Emotional Intelligence Questionnaire exploring well-being? So here you see the treatment group, here you see the control group. Just give you a moment to look at that. This was a discussion question I used for my statistics class, encouraging you guys to take some time to look at these two different groups and what the spread of the data looks like. We can see the normal curve superimposed on the data, and we can see it's a little bit different in each of the distributions. So again, the range is the max value minus the min value. The standard deviation can be calculated by this formula where S is standard deviation, and then we're looking at the square root of these other items. And if we look at the numerator, we've got sigma, which looks at adding everything together that follows, and we've got x minus x bar, where x bar is the mean, and then we're squaring that value. And then we divide all this by the denominator, which is in the number of cases or number of numbers, number of participants, however you want to put that, minus 1. So again, the standard deviation is a measure of the average amount of variability within a set of scores. And here, one thing to think about is we're looking at how far is each individual score from the mean. So in the numerator, we have each individual score minus the mean. Now, for some of these scores, they may be less than the mean, some may be greater than, so we would get negative numbers. The squaring takes care of that. If you have a negative number and you square it, you get a positive number. So we have that in the numerator to take care of that, and then we're summing those, and then we're taking the square root later on, which takes care of the fact that we squared those numbers if we think about the way this equation is set up. But the good news is with SPSS calculates the standard deviation for you in a flash. So chances are when you're doing research, you won't have to be using this equation to calculate it by hand, but it's great to understand what the standard deviation means in terms of the measure of average amount of variability within a set of scores, and the distance from the mean. Sigma here is the standard deviation in a population of data, or S, the standard deviation in a sample of data. And sigma squared is the variance in a population of data. So this just is a key for all the items in this equation. Again, you can see that S represents standard deviation for a sample. Sigma is the sum of whatever comes after. X is a score in a distribution. X bar is the mean or the average of all the scores. And N is the sample size, or number of numbers, number of cases. So I often tell students, just like when you're sending a text message, you might use an abbreviation like BRB for be right back, or LOL for laugh out loud. These are just letters that are abbreviations for other things. So try not to let the equation intimidate you when you see all these symbols or letters. Now, let's look at 3 different data sets, and we're keeping them very small just to make it a little easier. But the first data set are, and let's say these are each items on the Trait Emotional Intelligence Questionnaire, right? Because they're ranked from 1 to 7. So the first data set, you've got 3 7s, right? So not a lot of variability in that data set. In the second data set, you've got an 8, a 6, and a 7. So if we look at the range, that's about a 2 from a 6 to an 8, or that is a 2. And then the third data set, we've got a 4, a 7, and a 10. So the difference between the max value, the 10, and the min value, the 4, is 6. So we've got a range of 6. Now, what's interesting to see if you look at the mean of all these populations, starting with, or all these samples, starting with sample 1, 7 times 3 is 21, divided by 3 is 7, so our mean is 7. 8, 6, and 7, again, we wind up with a mean of 7. Likewise for number 3. So for all 3 data sets, we've got the same mean, but as you can see, we've got a different range, right? 0, 2, and 6. So we can have the same mean, but still have a lot of variation in the data. So just because 2 data sets have the same mean doesn't mean that there's the same spread and the same values within the data. The mean only is only one piece of information about a data set. So let's take a moment to review. What are the 3 measures of variance? If you said standard deviation, range, and variance, then you got that. What is the standard deviation? I'm not going to give all these to you guys because you can just go back through the video and answer these. I don't want to make it too easy. What is the denominator for the equation for the standard deviation? I'll give you a clue. It starts with an N. How, excuse the typo, that should be how is the variance calculated? And I'll give you a clue. There's one value that you square to get the variance. If the mean for 2 distributions is identical, like in the last slide where it's all 7s, is the variance also the same? And does SPSS calculate the measures of variance for you? And if so, which ones, and how can you easily calculate what it does not give you? Okay, well, I hope this quick review on the measures of variance has been helpful to you. If there are specific concepts you'd like to have explained in more detail, please let me know. Thank you for watching. Best wishes in your statistics journey. God bless. Thank you.